our Java track on the today's conference. Sorry for short delay. However, I believe that the wait was worth it because we have yet another Java champion. Marcin Grzejszczak from the Spring team will be talking about the observability. And to not waste your time anymore, I'm passing the mic to the Marcin. So the stage is yours.
Thank you, Artur, so much. Welcome everybody. I really do want to apologize for my voice. I am super sick, but I've decided that since I've already agreed that I'm going to give this presentation, I'm not going to cancel it. So yeah, welcome to the presentation entitled "Is Your JVM App Flying Blind? Unmask Hidden Issues with Observability Superpowers." Now, a couple of words about myself. So my name is Marcin Grzejszczak. I'm a Java champion and a developer at the Spring and Micrometer teams at Broadcom. If you want to get in touch, you can go to my Mastodon, Too Much Coding at Fostodon.org account, or Blue Sky, which is toomuchcoding.com. I'm not really active on Twitter anymore, but if you want to get in touch there, you can find me with the @mgrzejszczak handle. And there's the blog post, the blog toomuchcoding.com, where I have the list of my presentations and notable articles, books, and stuff like that. Normally, when I'm conducting this presentation, I'm doing a poll. However, I can't see you, so I can't do the poll. So let's quickly go to the next topic then. What is observability? Let us assume that for the sake of this presentation, we will agree that observability is how well we can understand the internals of the system based on its outputs, right? So we have some internals of the system, but we're looking at the system outputs to understand how internals are working. And now I have just literally in December started my 10th year in the Spring team, which is astonishing, like that how time flies. But it means that for a decade almost, I have not been doing a lot of production code. Although recently I did start a startup and I do have access to production code. But regardless of that, today I will be fully focusing on production work. I'm going to be delivering business value. So let us look at the system architecture. So in essence, there's going to be an edge service, and then this edge service, the UI. Let's say from the UI, when we click stuff, we're going to reach the T service, and now the T service does three things in parallel. Let's say two things in parallel. One is making HTTP calls and the other making messaging calls. So first we're going to be calling through a proxy service, which is a Spring Cloud Gateway application. We're going to be calling the tleaf service. That is a standard MVC application. And finally, we're going to be reaching the MySQL database. Next, we're going to be calling the water service directly from the T service and going to the MySQL database. And for the messaging infrastructure, we're going to go to through RabbitMQ to the reporting service that has a Vaadin UI. And we're going to be storing data in MongoDB. So we have imperative style of coding, reactive style of coding. We have relational database. We have a non-relational database, that being Mongo. We have HTTP-based communication and messaging-based communication. So we have all sorts of stuff there. Okay, so now I'm going to show you something which is absolutely amazing, because out of all the fantastic traits that as a developer I have, the best one that I have is the ability to create beautiful UIs. So this is the UI that I have been working on. It's like doing all the up-to-date stuff. It's AI-driven. It's Kubernetes. It's reactive because it reacts to clicks. You can see I can pick Sencha. And it's responsive because it responds to my actions. So when I click Sencha small, it works. If I do sencha large, there you go. It tells me how to brew it. I can pick different types of tea leaves, including this one, like English breakfast, large. Oh, that's highly unfortunate. Let me refresh the browser. Okay, internal server error. So I wonder what that means. Most likely that means I'm going to push over here to this, so that because I'm sharing one screen, so it's going to be better if you see me look at you here. So internal server error. Most likely there was an error that was internal to the inside the server. So let's try to debug this. Also, I have a mailing server running. But this is my email, and I see that the error rate is high. I got an alert. So let's look at the metrics. So if I refresh the metrics, we can see that the heart here is broken. But let's go through each of those parts separately. So what we have here is T-service latency. We can see the maximum latency, the 99th percentile, the 95th percentile as well. We also see throughput here. So we have around 5 requests per second, whereas 4.6 are success, 0.48 of errors. So that's also unfortunate, although for sure not in your companies, because in your companies you don't have any exceptions, any errors. But in this company that works that does the T service, we have a couple of errors that we know that have been there for years, but maybe it's time to actually fix them. So what we have here is the errors. Here we have all the different combinations of types of T and sizes of T. And to the bottom, we have a latency heat map. So we have buckets of requests. And we have from let's say 11 milliseconds up to 28 milliseconds, different amount of requests being there. So what we can see here is that we do have errors, and there was a problem with me actually going for the English breakfast. So what we can do is we can start with searching the logs, assuming that the logs are there, because I often have problems with the demo. So hopefully today the demo gods are with me. So what we can do is we can search for error logs in the application T service, and let's see about that. So yeah, we have quite a few errors. We can check the last like 5 minutes. So there's a lot of errors. Now let's try to search for those that are related to English breakfast, because maybe I was just unlucky that the English breakfast was a problematic thing. But let's check it out. No, so it seems that the English breakfast related errors in the T service is a big problem, because there's quite a few of those. So what we see here is that we have some sort of 404 not found. Now, I could SSH the machine and search for the logs, do like a grep on error, less, search and stuff like that. But there must be a better way, and that way is distributed tracing. So since we have Spring Boot based applications that use micrometer and micrometer tracing, we automatically instrument quite a few libraries, and we are able to also put some sort of a correlation identifier in the logs. So what you can see here with trace ID and some number, that means that now we can search for a trace view, meaning a visual representation of latency and errors within our system. So I can click that, but also that means, excuse me, that all the logs that correspond to that particular business scenario are having the same trace identifier. So now if I click this and close this for a second, we can see how, in fact, processing of that particular error request looked like. So here we can see that the whole processing took 15 milliseconds. it started with HTTP get to T English breakfast. And then we can see that we went to the reporting service through messaging to Mongo. Then we went through the T service to the proxy service to the water service in the database. And here we have the T service and the T leaf service. And take a look at that. Over here we have some sort of an exclamation mark, which means that there was a problem. Now, if we go here, we will see that there was a client error, resource not found. So we already know where the problem originated. Now, what we have only here is we're going to the database. So let's look into that. Over here, we have a query. So here we can see that this is the query that we have made to access the tea leaves. The tea leaf related information, and here we have the English breakfast as a parameter, and the result set is 0. So that means that we have not received any information from the database. So most likely, for the first time in the history of the world, the UI got updated and the database did not. So there has to be a way to fix that. Oh, by the way, if we click here, we can, let's say, correlate the two signals, one being the trace, the second one being the log. So here we can see all the logs related to this particular trace identifier that give us additional context in comparison to what we have by looking at the trace view. So now, how can we fix that? Believe it or not, but I had a request ready to insert the missing data. So what we will be seeing here, hopefully, is that the amount of errors should go down in time because I have added the missing English breakfast. Now, to confirm that this is the case, now you can see I can steep English breakfast because it's already there in the database. So now we can see that that we're going up with the number of successes and going down with the number of errors. Okay, so let's try to summarize that. In the meantime, at a certain point in time, we should be seeing that the mail system has sent the information that there's no longer a problem. Let's try to summarize that. So what we see here, so what we had was a database problem. So we started with a T service calling the proxy service that's called the T leaf service, and the problem was here in the database because we were missing an entry. So the actual problem was related to, like, seen in the UI and the alerting system. Metrics did confirm that there was a problem. Now, then we went to the error logs, and then from the logs, we went to tracing. We did analyze the problem, and we added a missing entry in the database. So now when we look here, we see that we have managed to resolve the problem with errors. And that could actually, conclude today's presentation. But something else happened. So the thing is that usually when you touch one thing and you fix a problem, then you get 5 other things. Now the question is, should you actually fix it? Because maybe it's better to have 1 problem instead of 5. But okay, let's not talk about philosophy here. Let's try to fix this problem. So here now we get the information that the latency is high. Let's look into that. Let's maybe refresh the Grafana. And now indeed we can see that we have success rate of 5, but the latency has spiked like crazy. What is going on? So to analyze that, we can assume that Grafana might be broken, but it's really not, because we do see that the histogram buckets moved up. So we have more requests within the buckets, like between 60 to 160 milliseconds. So how can we solve this, analyze this problem? You see, let me stop auto refresh for a second. What you can see here in the graphs are little dots. You can see dots over here, you can see dots over here, and you can see dots over here. What are those? These are so-called exemplars. That means that whenever, there is a some sort of an algorithm behind this, but that means that when metrics are gathered, and there was an active trace going on, every now and then that trace gets attached to a metric. So that means that when you have the logs and they have a trace identifier, you have a dimension of logs or a signal of logs that has a correlation to the trace signal. When you have metrics and you have exemplars, you have a correlation between the metrics and the tracing signal. Why does it matter? Because we can take a look at a trace from the past when everything was fine, and we can compare it to the trace from the situation where something went wrong. So here we have the 50 millisecond positive scenario, let's call it like this. If we split the view, now we can compare it to the non so great example, because here we have 160 milliseconds. And now if we start doing the analysis, we can see that here we have similar results, 5 milliseconds, fair enough. So Mongo is not a problem. And now when we see here, we used to have 30 milliseconds. Now we have 130, more or less. So maybe here is the problem. So maybe the proxy service is the problem. Not really, because that is being blocked on the call, HTTP call, to the water service. And now in the water service, we can see that indeed we're blocking for a very long time. So I have a hunch that the problem might lay with the database, because here we're getting a connection and it takes some time to actually get it. So how can we confirm that? Let's take a look at the dedicated metrics for the connection pools. Here we're using Hikari. So our potential culprit is the water service database. But first, let's look at the tleaf service, because that seems fine. So let's look at the tleaf service, and we can see that the connection times are fine. Here we had a small spike, but other than that, it's like very steep. Now let's look at the tleaf service. The tleaf service, let me refresh this. Oh, because we were looking at the tleaf service. So now the water service, and here we can see that the usage time has jumped to around 50 milliseconds. Let's take a bigger look here. You can see there is a spike to 50 milliseconds, and now it's getting it's the same all the time. So indeed, we can see that something happened with the database. So what can we do about this? There are different ways to solve this problem. First of all, we can file a ticket to the database team where we will ask them to look into this problem. In the meantime, we could introduce caching, where we would minimize the time that we spend in the database. However, there is yet another problem. Yet another solution. So the thing is that my applications are not directly calling the database. They are calling the databases through, or one of them is calling their database through a Toxi proxy. Toxi proxy is a Docker image that can introduce fake latency. So what I did right now is I called a special command that disables the base latency, and now we should be seeing that the latency falls in time. So when we do 5 minutes of the time at which we're looking, we should be seeing a gradual fall of the latency. You see, it's going already down. Okay, so let's summarize this part. Oh, maybe one thing I would like also to show you. Let's close this one. Let's get back to our analysis over here. So let's close this one. So now we're looking again at the trace view that represents the problematic case. So via the trace identifier, we can correlate logs and traces. Via exemplars, we can correlate traces and metrics. However, or actually metrics and traces. Now, if we want to visualize somehow metrics that correspond to the given spans, given traces, we can also do that. How can we do this? So in Spring, we are using Micrometer Observation API to instrument different libraries like Spring Web, Spring Web Flex, etc. The thing is that we instrument once and we get multiple benefits out of it. For example, we have the same key value pairs for metrics and for spans or part of it. So here you can see the span attributes. So these are the key value names that I'm talking about. So for example, exception none or method get, etc. Since we are using the same library and same set of data to do the instrumentation for the metrics and tracing, what we can do is we can prepare some predefined parameterized metric queries, like for example, latency or throughput or something like this. So if you click here, we get a parameterized histogram quantile for a metric called HTTP server request seconds bucket. So that's a histogram, and that's a mux, right? So what we're searching for are metrics for the given tags: application T service, exception none, method get, org T house, outcome success, status 100, URI T name, and those come from these span attributes. So this is pretty amazing because we can literally look at 3 signals at the same time. We can have traces to the left, we can have metrics to the right, and we can also look at the logs, right? I'm not an expert in Grafana, so maybe we can split this somehow horizontally, but we can have the 3 signals there together. Fantastic. So now let's look at the summary of this part. So here we had a latency problem. So we started with the T service, then we went to the water service, and the problem was here in between the water service and the database. So what happened was we had an alert about latency, then the metrics confirmed that there's a problem. From metrics, we jump to traces. So from metrics, through the exemplars, we go to tracing. Since metrics and traces share the same tag, we can check metrics for given trace arguments. So meaning span values, span attributes. Then we compare it to traces, and we can see that the latency is there. We check that it's indeed the problem with the data source metrics, and finally we disable toxiproxy. So let's check the alerts. We have resolved the high latency T-house problem with the latency. Amazing. Now what is this? Now we have high error rate again. Let me refresh this. Come on, this is crazy. What a day. So I fix one thing and then I break another. So what we have right now is the latency dropped, but now we have a pretty much fixed rate of errors, around 3 and around 2 of successes. Why is that? What we can do is try to check maybe other services, dashboards to see if everything is fine. So on the reporting service, we can see that it takes a long time to actually run database queries, but it's pretty the same. There are no errors here, like everything seems to be fine. But take a look at that. Here we are at the proxy service, and we can see some problematic things like quota denied, quota allowed. What is this? I understand throughput, but what about this quota thing? So I don't know about you, but I mean, I love the documentation, but I am not fantastic about in terms of writing it. I mean, I'm making progress, but what I prefer that could happen is that the docs would automatically generate themselves. So how can we do that? So with the Spring team, we believe that the documentation could be written by itself. This is why we have solutions like ResDocs. But in terms of observability, we believe that if you create your observations in a predefined way, using certain having certain assumptions in mind, then what we can do is we can scan your sources and generate such a documentation. So I went to the proxy service and I'm checking the documentation that got generated from the sources. And now what we can see here is observation related to request quota calculation. In case of going over the maximum allowed request rate per second, rate limiting will be applied. Okay, so we have some quota. And by the way, this is not an academic situation. It's just a true thing from one of my friends from one of big companies that do platforms, that they do have this problem. So I am literally showcasing you an actual problem from production. If we look at spans, we can also see that there's like information about maximum rate request, number of accepted requests, quota allowed request rate in total time. Okay, so now I know more. So what we can do is I can actually search for spans. Let me go to tempo and let me search in the proxy service for such a quota related spans whose tag will be quota allowed equals to false. Will I find any? I did. So let's check it out. Now, if I check this out, we can see that indeed we go to the T service, to the proxy service, and now at the quota we are finishing. And here we can see that quota allowed was false because the maximum rate was 2 and we went over it, right? So how can we fix it? The way to fix it would be to ask our managers to swipe the card and to increase the quota, which I actually did at the very this moment. So what we should be seeing is a fall in the error rate and the increase in success rate. So let me summarize this part. So we had the flow going from the T service to the proxy service. The problem was here, and TD service and the database. So we checked the trace where latency was present. We went to the proxy service dashboard. We checked the proxy service automated documentation. We came to the conclusion that we reached some quota. We asked our managers to swipe a card, and now the problem is gone. I just got the information that we have around 10 minutes left, or even a little bit less. So I will show you just one more thing, and I think it would be very beneficial to have the round of questions, time for questions. So let us now see that we have resolved the problem with the error rates. And if we go to the T API, we can see that we're back to the success rate. Okay, I'll try to show you two more things. One is that if we go to the reporting service, we can literally see that it's super slow. So the metrics for the Mongo part give us a lot of information about this particular problem. So what we can do is I actually asked ChatGPT, because I'm not an expert with Mongo. I said, hey, what kind of a problem can I showcase? And the problem was related to, obviously, to latency. And ChatGPT told me, hey, how about you show how you introduce indexes? And I'm like, wow, that's a great idea. So what I have here is I have Mongo Compass that allows you to connect to Mongo. Let me make it bigger. And I will go to the order collection. And what I can do is, if I go to order database, order collection, I can add an index. So now if I add an index, let it be ascending, on a field tdiff, because this is the type that is pretty much fixed, so there will be a lot of reads, very few writes. If I add this, and it's being added, it's around 5 megabytes. So now if I go back, hopefully we will see a steady, let's say, fall in time of the time required to perform the queries, unless some, oh yeah, it starts to go down. So to show you that how small will be the time required to run this. You'll see that in a second. So in the meantime, let's try to summarize this part. We had a UI for this. So now we can see that if I search for Sencha, it's fast. If I disable the latency, I don't remember how it types. So now it's really, really fast. Okay, I made a typo. You get the idea. So now it's super fast, and it is confirmed by the logs. Take a look at the dramatic fall from 0.5 of a second. We went back to nothing really. So this is really impressive. Let's summarize this. So we started with the T service. We went to the RabbitMQ, to the reporting service, and MongoDB. And the problem was here. We saw through the metrics and the UI that that is slow. And we went to Mongo Express. Oh, if we went to Mongo Express, you can see that we have around 1 million documents. So this is with such a amount of documents, the problem starts to be very big. We asked ChatGPT what to do about this, because every presentation needs to reference an AI right now, otherwise it's not trendy. And we added an index, and we saw a massive drop in the database latency. Okay, so last thing before we go to the questions. So all of this works thanks to micrometer and micrometer observation. And we said that how well we can understand the internals of a system based on its outputs. So the outputs were metrics, the outputs were logs, the outputs were tracing, but we can do even more than that. So for example, it's over here. My very good friend, Jonathan Ivanov, has created a visualization using tiles, where the green tiles mean that the request was fine, and the number here represents the latency. So of course, we don't have time for this right now, but I could also show you a case where we are playing music, depending on whether you have an error or not. There are drums and trebles and stuff like that. So you can visualize this in a different way, right? You can have different types of signal. Okay, let's summarize this. We were jumping through different pillars of observability. Logs through traces to metrics. Logs through the trace ID to traces. Traces through tags to metrics. And metrics through exemplars to traces. And all of that works because Spring projects use micrometer observation to instrument their code. And if you add actuary to the class path, Spring Boot will configure micrometer observation for you. Now, micrometer core metrics uses micrometer observation, and micrometer tracing does as well. So you instrument once with micrometer observation. You do not talk about metrics or tracing then. And basing on your class path or your configuration, you start introducing features like metrics or tracing. With micrometer observation, we instrument once using same set of tags for all signals. Of course, low cardinality, so those that do not vary a lot in time, go to metrics. High cardinality and low cardinality goes to tracing. And Spring Boot will set everything up for you when on class path. So if you want to see the code, you have to go to github.com/Jonathan-Ivanov-Thouse, and there's a 2024-Marcin branch. So I think we have 1 minute for questions. So that would be all from my side. And Arthur says that we don't have time for questions.
We don't have time for questions, exactly that due to delay. Sorry for that. However, Marcin, that was wonderful presentation, and I'm sure that everybody will be able to find you on Twitter. So thank you very much for being our guest.
Please rate my talk.
Yeah, the talk was great. I will rate it for sure. So thank you.